Hi, in this video we're going to be talking about Hess's Law. So this is the overall change in enthalpy, aka deltaH, is the sum of the changes for a set of steps in a reaction. To show you how Hess's Law works, I'm going to be doing a series of examples. So first it says, find the deltaH for the reaction below, given the following reactions. This over here is our goal. Basically, using these steps, reaction steps, we need to form this reaction. And this goes for all 12 practice problems. Over here, it tells us the answer. So in the end, we'll know if our work is correct or not. First, let's see. We want PCl5 gas making PCl3 plus Cl2. First, let's see the reactants. We have a PCl5 on this side. So we know that this reaction is going to stay this way. Now let's make sure our coefficients are right. We want one PCl5 over here, and in this there is only one PCl5, and it's in this reaction over here. But this has 4, so we're going to have to divide this whole reaction by 4. Now this will become a 1, this will become a 1 over 4, and this will become a 10 over 4. This is also going to be divided by 4. So what is 3438 divided by 4? 3438 divided by 4 is 859.5. So our new deltaH for this step is going to be 859.5. Alright, now that our PCl5 is done, let's cancel our P4. Because in our goal, there is no P4 at all. So this has to be cancelled out. And in order for this P4 to cancel out with this P4, the coefficients have to be correct. This is 1/4 of a mole of P4. So we're going to have to divide this upper reaction by 4 as well. Now this will be 1/4 over here, this will be 6 over 4, and this will be 4 over 4, which is 1. This has also has to be divided by 4. So negative 2439 divided by 4 is negative 609.75. Now P4 and P4 are cancelled, leaving us with 3/2 Cl2, and this will be what? 4, 2, 5 halves on the bottom. Now this is a 3/2, and this is a 5/2. So we can do this will get cancelled out, and this 5 over 2 minus 3 over 2 will become 2 over 2, which is 1 Cl2. 1 Cl2 matches out 1 Cl2 in the goal. Finally, we have PCl3. Our 4 over here, our previous 4 PCl3 has been divided by 4 since we divided the whole reaction by 4, and now have 1 PCl3. So circling out everything we have left over, we have PCl5 making PCl3 plus Cl2. This matches our reaction over here. Now to find the total deltaH reaction, we'll be adding our deltaH together from our steps. So 859.5 plus negative 609.75 gives us an answer of 249.75, which rounds to 249.8, which matches our answer. And make sure you don't forget our units, kJ per mole. Now, if you didn't understand how this quite works, don't worry, because we're going to be doing 11 more examples. So number 2, the question is going to be the same. We just need to find our deltaH reaction for this goal reaction. This is the goal that we want to get, alright? We want to manipulate these steps to get this one. So first we have 2 CO2. Let's see, which side has CO2? CO2 is over here. So in order to do this, in order to move the CO2 to this side, because it is in our reactants, we have to reverse this reaction. Now reversing this reaction will cause this to become a positive 2A3, positive 2H3. Now this whole thing will be reverse. 2CO2 plus 3H2O makes C2H6 plus 7 over 2O2. Now C2H2 is also on the right side. Now this over here, it is on the left side, so we have to reverse this reaction as well. Now when this reaction gets reversed, this one becomes a positive as well. So positive 94.5, positive 94.5. Over here, this will be this will be C2H6. C2H6 plus plus makes 2H2 plus C2H2. C2H6 over here can be cancelled out with C2H6 over here, because one is in reactant and one is in product. So let's cancel these two out. Now our C2H2, we need a C2H2 in the product side, so we can keep this C2H2, and we can keep this 2CO2. Now we have 3 H2O over here, and let's see if there's 1 H2O over here. Now we want 1 H2O in our final reaction, so we're going to multiply this by 2, and turn this into 1 oxygen. Now this 2 H2O is on the left side. We want it to be on the right side so that it can cancel out with our 3 H2O on the left side. So we're going to reverse this reaction as well, making this negative 71.2. But watch out, we also multiply this by 2. So when we multiply this by 2, we're going to have to multiply this by 2 as well. Now make sure you keep the negative, because it still is negative. So 71.2 times 2 is turns into negative 142.4. You keep the negative sign because we didn't reverse the reaction. You only change the signs when you reverse reactions. So this will become a new negative 142.4, and this is going to become H2, 2H2 plus O2 making 2H2O. Now we'll be able to cancel this out with this 3H2O, forming this 1H2O. 1H2O matches our 1H2O over here. Now finally, we need 5 over 2 O2. We have 1 O2 over here, which is also 2 over 2, right? 2 over 2 is 1. 1 O2 over here. Now 7 minus 2 is 5. 5 over 2 O2. This is on the reactant side, and this O2 is on the product side. So this will be completely canceled out, and this will form 5 over 2 O2. Now this matches this. Finally, our 2H2 and 2H2 are left over. This one is in reactant side, and this one is in product side. So they will be able to cancel out. Now we have everything that we have. So we have everything we need to form our reaction. We have 2CO2 plus H2O making C2H2 plus 5 over 2 O2, which matches this one. Now we're going to add all three of these together. So 94.5 plus negative 142.4 plus 283 gives us 235.1 kJ. Since out of the three we're adding together, the one with the least amount of decimal places is this one with 0 decimal places. This one with 0 decimal places. So our answer will have 0 decimal places as well. And this will be 235 kJ, which matches our answer of 235 kJ.